Good morning. It's time for the stream. And it's time to figure out what is going on with the LEDs on this half. So if you're just joining us, the past, or this week, I guess not quite the past 2 days because I didn't stream yesterday because my neighbor's construction crew was on site, and that's all you would have heard. That and me being frustrated with them being loud. And it's fine that they're loud. They're a construction crew. My only worry, or my only wish, is that they had a schedule that I could work around instead of, hey, by the way, they're going to be here today. But that's okay. Because, you know, that's sometimes what life gives you. So the past couple days, I've been building the TBK Mini, or the Bastyl Mini. I don't actually know which is the official name for it, but whatever. From Bastard Keyboards. It's a sculpted, 3D printed keyboard that's very corne-like in its key map and thumb cluster and stuff. It has flexible PCBs, so you can put the PCBs in here, and this is actually the wrong side, but this is, you know, this isn't the correct PCB for this half, but it's a good thing. Illustration. And yeah, so it's got a controller section. It's got a main key well section and a thumb cluster section. It also has matrix RGB, which is what I've been working on, or what I mostly worked on last time. It has very floppy ribbon cables holding things together, which is extra fun. I did manage to, or I did order a third hand tool, but it doesn't arrive until this weekend, so it's not going to arrive in time for this build. At least hopefully I will finish this build before this weekend. But it will be helpful for future builds because I do struggle with, you know, positioning things and stuff like that from time to time, so it'll be good to have. Where I left off on Tuesday, I had this side working all of the LEDs on the main board, but these three weren't. And then as I started messing around with it, it went back to where just this column was working. So I kind of was like, you know what? I'm going to set this to the side, and I'm going to work on the other hand. And the other hand, I got fully assembled. This even types. Like, I can type with this by shorting the bridge, or shorting the switch holes. So this side works completely. All the LEDs work. At least one of the, or a couple of the switches work. I managed to find the enter key. So this one is working. It's ready to get assembled into its shell. And if for whatever reason I can't get this working right out of the box, I'm just going to go ahead and start assembly on this side, and I'll just keep coming back to this other one and until I get it right, because I really don't want to assemble it all until I get all the LEDs working. I feel like that'll just be a lot easier to do without it fully assembled. So, all that being said, today's goal is to finish this whole thing. And if I can figure out, if I can fix the LED problem within half an hour, I feel like I should be able to get the rest of this done today. Even if it turns into like a little bit longer stream, but that's okay, because I have a timer set for banana time. So when I get frustrated and I'm like, I hate this, why do I even do keyboards? This is terrible. I can go have a banana, refill my water bottle, and then come back and be recharged and ready to go for another hour or two. So yeah, that's the goal today. Finish this up. I'm hoping this is a pretty easy fix. It's just a, you know, a messed up trace or something, I don't know. But I've got the meter, and I've got soldering iron, and some extra LEDs, and we'll see how it goes. Yeah. Alright, let's get started. First, let's even reconfirm that the problem is still the way it is, because who knows? You walk away from it, you come back, and everything's different. But no, we still have these three working, and this one does not. I already replaced that LED. I had all of these working. I don't know what could be wrong, but I'm gonna try some stuff. You know, I've tested for continuity between things, but let's just test it all again. So, one thing I wanted to do, and I'm going to put this so you can see it, hopefully, because you probably can't hear it. Okay, I need to tape this or it's going to drive me nuts. Because I'm sure that's really annoying on camera. Because it's annoying to me. Okay. There. Now I won't wag around so much. Okay. So what I want to do is, this is the ground pin. This lower left one here. And we've got ground here. This is the power, the ground and the VCC for the LED lines, because that comes off of the main controller board onto here. Okay, so ground is connected through. VCC is the opposite corner. That's connected through. Then this is the input, I believe. And this is the output. So the signal is getting from here to here, which is good. And then, as we know from previously, this is the output of this one, and it goes into this switch here. So the path for these LEDs goes here to here to here to here to here. And it doesn't obviously jump across there. It comes up through here and around. And I traced that trace with the microscope, and it looks fine. But we don't even need to trust that trace, because I can just touch here. Okay. So we've got continuity between those two. So, in theory, that should all be working. Now, one thing I didn't check was if I have continuity there or there, and I do. So the voltage, or the high should work, or VCC should work. So I don't really know. You know, I look at the solder joints. Let's bust out the microscope again. Nope. Microscope isn't working yet. Oh, because it's not plugged in. Let's try plugging it in. There we go. So we've got the microscope here. We're going to look at the solder joints on here. Ah, I see, the light wasn't on. There. Try to get that in focus. There we go. So solder joints look good, and I've, you know, tested continuity. So since I'm touching on the top of the solder joint on both sides, that's proving to me at least that it's connected through the trace, so that it's making a good solder, or making a good connection to the board. Connects through the trace on both sides. So I don't see any reason why this shouldn't be working. And so bizarre to me. So we're gonna do it again. I think I'm gonna just swap out the LED. That's weird because I just did that. But who knows? Maybe I damaged it. Maybe... Who knows? Oh yeah, before I do that, what I want to do is get my wick out. We're going to trim the end off here. And just suck some of that excess solder off of there. Make it a little bit easier to get off and clean up. So for these, what I do, since I'm already kind of writing this LED off as dead anyways, I just pull some of the solder off with some wick. And then I use edge cutters or some other cutting tool to just cut the LED out itself, because then the legs come off individually. Makes it a lot easier. Don't have to worry so much about lifting pads like I just did right there. Oh joy. Yep. Lifted pads. This is gonna be fun. Fortunately, it's still stuck on there. I didn't rip the pad off, I just lifted it. So I should be able to push it back down. And then just trim the excess off here. Well, that did it. Okay, so there are going to be a couple of bodge wires here, because I lifted pads. Great. Well, I mean, you say that, and I can believe you, but I don't see anywhere that would have happened. Although I didn't check for not continuity, so maybe I should have. But it's okay, because now we have a completely different problem, which is I have two lifted pads on here. Which means I need to connect, so this is the data in, this top one here. The data in for that LED, which means the lower right one is the data out. So I need to connect this lower right one to the upper left one on this. And then the top right is VCC. So what I'm going to do is I'm just going to drag two bodge wires down from this LED. So let me get some wire. Yeah, this is not my first lifted pad either, but it's always annoying. Okay, so we've got a couple of wires here. I'm gonna go ahead and get the LED tacked in on this one side. Okay, so ground should go on the lower left. And actually, I'm going to just try to get a little more of the solder off here. Carefully. Because one of the things that can happen when you desolder is that the adhesive holding the copper traces to the board melts. And makes it easier, or even like you may even just as part of trying to desolder, just straight lift the pad off. Okay. So I want to get, so I forgot also the legs are still on here from the previous LEDs, so they're gone now. Okay. Now just try to clean up this a little bit. Alright, now there should be enough still on there to tack it into place. It looks like I might not have to run a bodge wire on this one. Let me just check here. Oop, okay. Yeah, let me add just a touch of solder onto this pad. So it has a little more to melt, stick to. Okay. So, addressing the fact that I just made a mistake here. That's actually one of the reasons I like doing this stuff on stream. Because my goal with the stream is to not just show you, like, oh, look, someone who's good at soldering can build a keyboard and blah, 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 blah. It's like, no. One, someone who is, I guess I would say, moderately good, I don't know, at soldering, still makes mistakes plenty of times. But also then you get to see what I try to do to fix it, right? So in this case, I'm looking at the board here and I've got a little bit of material right here still on the PCB. So I'm gonna try, well, actually, if I show you, let's go back to the microscope view. So I've got a little bit of material there still on the PCB. I should be able to bridge to that pretty easily and get a good connection. The way I'm going to test to see if that will work is I'm going to take my leads from my multimeter and I'm going to put one of them on the pad, not on the leg, but on the pad next to that. And then up onto this upper left leg here, because that's where that connects to. And if I get continuity, then what I know is I can solder to that. So all I have to do is make a solder connection to that. And this solder connection, while it is a bridge, because there's no pad material left underneath the leg there, it's no worse or really any different than soldering the non-E minis, because you're making a bridge. Like, you're just connecting across there. It's not a big deal. So it should be fairly straightforward. This one, this top one, as you can see, there's no pad material left at all. So I could probably, you know, come over to this trace and try to get some of the copper there, but I'm not going to do that. I'm going to just run a little wire from the top right pad on this LED, and that'll give me the power that I need. If this was a single continuous board, I would actually use this other one over here because it's closer physically. But since they're separated and they're going to be flexy and stuff like that, I'm not going to run it between boards, or between, you know, parts of the same board. I'm going to run it right from one LED to the other in the chain. So let's first test this pad here on the right, or on the bottom, I should say, and test that that has continuity. I want to take a closer look at this here because I can't tell if that is a via to the other side and that's where the trace is, and this here is VCC. Can't really tell what's going on. I'm going to clean it up a little bit. I'm going to look at it closer with the microscope, kind of try to get an idea of what's going on with the traces there, because that may be what was causing the problem before, is that trace was maybe soldered to this pad. I don't know. I would expect that to affect the next LED in the chain after this one, not this chain or this LED, but who knows. So let me get in here and do a couple things and we'll see what happens. So I'm going to turn the microscope off. A little alcohol, swab this up a little bit. Okay, I'm gonna actually hit it directly. Okay, so I'm gonna look at this with the microscope real quick, but because of how I'm doing it, it might make people sick, so I'm not gonna show it on camera or on stream. I don't know what is. And my tweezer tips are bent. That's fun. Okay. Because that looks like it's coming off of the VCC to the other side of the board here. Yeah, those traces are just really close to each other. So maybe that was bridged on the output there. That's weird. I still wouldn't expect that to affect this LED, but who knows? Maybe it's slurped away the power. Okay, so we wanted to test continuity between this pad here, this little bit of teeny bit of pad here, and this. And I don't know if you can hear it. Nope, but it's beeping. So there is continuity between that pad, so I just need to solder to that pad and one little bodge wire, and we should be back in business. So for this, I'm actually going to steal a technique that I saw on Fustan's Twitter for bridging the non-E minis, where he fluxes up the pad and the leg, or on the non-E minis, both pads, gets a little dollop of solder on his iron, and then just kind of flops it on there. And it just sticks perfect, like that. So now if we look close, we've got a bridge to that pad. So, whoops. Okay, I need to get my macro pad for switching scenes going, because that'll make that a lot easier. I just quick hit a button instead of having to mouse with my left hand on a trackball. Yeah. So let's double check continuity between this leg here, away from the pad, and then the other side. And we've got continuity. So that should work. And then we just need a little bitty wire from here to here. And I cut way more wire than I needed. Not that I'm going to use all that wire, but just because it's easier to work with a short piece than the whole roll. And I'd rather have too much and throw some of it away than too little and have to start over. So for this, what I do, this is 28 gauge wire. It's really hard to strip, because this is stranded 28 gauge wire, which means there are individual strands of copper in here. There's you can't see it, and I'm not going to be able to get it close enough, and I don't want to flip back to the microscope, but there's like probably 8 or 10, maybe more strands of wire in there. Really, really tiny piece of wire. So it's hard to strip because whatever cutting tool you're using is probably sharp enough. Like even my teeth, I've tried it with my teeth. Sorry, I just got distracted by Leah's message. Yeah, it was hard enough to find this, so I didn't worry about stranded versus not. I just I need some wire. But anyways, it's 28 gauge wire, so it's really small, really hard to strip. So I just use an X-Acto knife and just kind of cut through the casing and then roll the wire up and down the knife and just gently do it, and that does it enough, usually. Oops. So then what I do is I use my tweezers and just twist the tip of the wires together here a little bit. Now, some people would want to go ahead and tin this. It's hard to do because you're holding your solder and your iron, or you're just dropping a ball of solder on there or whatever with no flux, or maybe you want to use flux, or it's just a pain. So what I do instead is I'm going to put this end onto this pad, or onto that leg. I'm just going to flux that real quick. Flux this real quick. And then put the wire on where I want it to go. Carefully. And just kind of smash it in place with the iron. And hope it stays. Sometimes this works well, sometimes this takes a minute. Okay, that's good enough for that, I think. And then I'm going to just add just a dab of solder on there to make sure it's good. Okay. Now the other end. And I put it on the wrong one, but that's fine because it kind of crosses here, and we're just gonna go with this. That's what happens when I'm paying attention to Leah and not my work. So for this one, since I'm just doing it straight onto the leg here, I want to first not melt that. Okay. So I want to get a little bit of tin on this pad, and my soldering iron tip is just not happy with me today. Okay. Get just the smallest amount of tin going on this pad. There we go, or on that leg. That's fine, Leah. I'm just giving you shit. And you're not sorry. It's fine. Okay. So this is a little more wire than I need. But because it's coming across here and stuff like that, and since it's contained inside of the case, I don't really care that it's a little too long. I'm not worried about just getting snagged on anything. So I'm just going to leave it as long as it is. Okay, roll the thing. And there's a little more on there than I really wanted, so I'm going to just trim the tip off there. You're not sorry, and you shouldn't be sorry. Okay, so I forgot about the flux. Let's do some flux. Let's do some flux here. Okay. I'm sorry, that's really hard to see for y'all, but yeah. Okay, so push that right onto there. And we've got it attached. I'm going to put just a little bit of extra solder on there if I can. Just to try to get a good joint. Okay. So we will double check that we've got... We'll go from here, because the VCC should all be connected anyways. We've got continuity. So, in theory... this should work. I am going to test as who suggested it? Luca. Apparently you retracted your message, but I'm pretty sure it was you. I'm going to test across. So I'm going to test to make sure that VCC and ground are not connected, because that wouldn't be good. They're not. I'm going to test that these two aren't connected. They're the signal lines. They are connected, but through the LED, so that's fine. I'm going to connect that the signal wire and ground and VCC are not connected. And it oddly looks like there is... I've got a diode in upside down, is what it is, I think. They look all right. No, they look fine. I don't know. Sorry, I meant an RGB upside down, not diode. Like switch diode. Okay, well, it doesn't matter, because they all work now. So, hey, I guess it was a dead RGB. I don't know how or why, but it was. But also, you can see that despite lifting 2 pads, I was able to fix those RGBs. I still don't have the thumb cluster working, but that's okay, because we're at least back to where we were. Like, I had this working, and then I worked on the thumb cluster, and then I went back, and this stopped working. So now we're at least back to, you know, partially there. So I'm going to now test that we have, and I think I already did this on Tuesday, but I don't remember, so I'm going to do it anyways. I'm going to test that we have continuity all the way through from the controller board all the way through to the LEDs over here. So we're going to start with VCC, and this is, you know, this is where I wish I had my helping hands. Okay, there we go. So VCC does not, no, okay, that's good. We've got connectivity there, there, and there. Okay, let's go for ground. Ground, ground, ground. Now, the output of this one is here, and that should go to the input of this one. Okay, well that's a problem. So let me just verify my brain is working correctly. Okay. I need to think about this because these are upside down from the other side. So this is the output, or this is ground. Opposite ground is the output. So the top is ground, opposite ground is the output. So we go output, and then next to ground is the input. So we've got continuity there. Output, input, continuity there. Right? Yeah, output, input, continuity there. And then the resistor in between. Oh, between here and here. Why is, just out of curiosity, why is there a resistor and capacitor on any of this, to be honest? But also on the thumb cluster. I think that's what the problem is then, because the output of this to the input here doesn't work. But if I go the output of this, oh. Do I have a broken connection in? No, that works. Okay, so it doesn't appear that this is connected to this. Okay. Just put a little more solder in here. It's weird. Why is there not continuity between this and that? Okay. Okay. So this should be the output from that RGB, and that should be directly connected to it because it's the line from the output to there, and it's not working. No. Yeah. That's the output. That's the output. So this should go to that. All right, let's bust out the microscope. Okay, so the bottom goes to a via. There's nothing wrong with coveting thy neighbor's keyboard. I believe that's not in the Bible. Okay, so that solder joint looks fine. It connects to a via. And there's actually a via right on top of it. So 3 in a row, it's the bottom one. So we flip this over and look, and it should be the top one. And that connects to there. And then the top one here connects. That's not right. Because that looks like it goes to... Now there we go. Okay. So yeah, it should connect straight across over to here. But for some reason, it is not connected. Let's see if I can get a decent focus on that. I mean, maybe that is just not there. Okay, well, I am going to hunt on this for a moment. I'm going to try something. So I'm going to plug this back in. And please tell me all of them work still. Okay, they all work still. We're going to connect the output here with this. Just to see, and we got nothing. What about the output here to the input here? Nothing. Okay. This is the fun part of building keyboards, folks. Troubleshooting LEDs. Why the hell aren't these working? Okay. So output from here. This should connect to the input over here. No continuity. But if I connect it directly, it still doesn't work. Strip's good. That connects through. This doesn't. So it's between here and here. I mean, even touching it right there works. How about on this via? How about on the pad on the other side? Yeah, that's not... No continuity there. But like I said, I should be able to touch these two right here and bypass that whole thing, because these are conductive tweezers. And it's not working right now because it's not plugged in, but let's see. Let's try plugging it in. Okay, we still have all of our keys lit, or all of our LEDs lit. I mean, maybe this LED is just not outputting, but I can't get connectivity bypassing the LED, so... How about going directly to in? How about this to in? That should light that up red, and it doesn't. I think there are multiple things going on here. It's the problem. Okay. We're gonna unplug this. Do some more continuity checks. So ground to ground, 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 VCC to VCC, VCC, VCC. This pad here to data in. Nope. Okay. I am going to I don't know what I'm going to do. Try one more thing here. Okay, connect here to there. That's good. That's going through a resistor 0.275. And that should be... $329 ohms. 330 ohms. Seems right. Yep, 331. Okay. So the resistor's good. Yeah, it's just here. It's just between these. Screw it. Guess what? It's time for another bodge wire. I'm just gonna bodge straight off of this pad into there and see what happens. I'm looking at the trace. I don't see any problems with the trace. I don't know what could be wrong, why it's not working. I already cut some black wire, so I'm not gonna dig out more. So find it. It fell on the ground. And before I go through that, I'm actually going to check real quick just to make sure there's not continuity where there shouldn't be. So this doesn't have continuity with ground. And it doesn't have continuity with VCC. Oh, wait. I'm waiting for it to beep. And it's on the wrong mode. So it has continuity, no continuity. No continuity. Hey, if a keyboard doesn't have at least one bodge wire, is it really handmade? Or is it PCBA? Ah. Okay, so then we come over here. So I figure about that much. A little short. It'll do. This is gonna be the fun part. Not burning myself. Okay, so there's a little mini bodge wire. Now, let's test for continuity. Data in. Okay, we've got continuity there. And let's measure across the Resistor just for grins. Okay, looks good, I think. All right, that did it. So we've got these working. We've got these working. And I melted another hole in my mat. So now we have this side working. Hooray. And that is an hour in. I am going to, real quick, refill my water bottle and grab a banana before I get too frustrated. I'll be right back. So I've heard with bananas there's something where you're supposed to open it from the bottom. Some people say it's easier to eat that way. I don't understand that. It's not like bananas are hard to eat anyways. And then it's like 1,000 times harder to open. Because you don't have a handle to like wrench on. Especially when a banana is really good and ripe, this thing just falls off. I don't get it. But I feel like bananas are the perfect snack. Because they're nutritious. There's a lot of nutritional value. Yeah, why wouldn't you open the banana from the top? Yeah, but then you mush the whole thing up. I don't get it. With the top, you just grab this and put your fingernail in there and just go think. Well, if they're not soft, you reach for a different one that is soft. Next, you're going to tell me your cream soda is red. Okay. Banana is eaten. Water is refilled. Let's do some more of this. Okay. So, as yesterday, we've got a bunch of little ribbon cables to do up here. This is all for the matrix wires. So, you get 2 from the controller to the main PCB and 1 from the main PCB to there. To the thumbs. And, like yesterday, I need to remember that the wires go into the controller from the top. And this isn't the right one. But, I don't think anyways. Oh, okay. Oh, that might be a problem. Nope, that should be fine. Okay, long enough. No. Yeah, that might be a problem reach-wise. Let's see. Let's just plop this in here real quick before we get too far. Down this path. Okay. Oh yeah, there's plenty of room. Okay. I was just making sure that these wires were long enough to fit. Whoops. And they are. So, okay. I mean, they came long enough to fit, but I apparently soldered them into the wrong side of the controller breakout. So there was some question of whether or not they would fit. Alright, so let's go back to the guide. How about that? Whoops. Cancel that. Okay, so we do the 5 cable. Goes to C6 on the controller to C3 on there, so on the PCB. So C3 to C6. Okay, so these ones here to these ones here on the PCB. Now I'm curious if soldering both of these to the controller and then doing it to the PCB, or the other way around, is easier. I think soldering it to the PCB first is easier because I can use the PCB to hold this in place. Like I did yesterday, where I stick this in here and it holds it in place. I think I'm going to try that. I mean, the worst that happens is I blow up the planet, right? So, no big deal. We don't need that anymore. Hello, Lensevel. Welcome to the stream. Thanks for stopping by. Okay. I almost went like this, which would have been really bad, because the controller would have been on the wrong side of the PCB, and that would have been not fun. Okay. Let's pop these out. And okay, C6 to C3. Okay. Just dabbing some solder on there to hold it in place, so I can solder the rest of them in peace. Oops. Yes, yes, my third hand tool is coming this weekend. I can't wait, believe me. Nah, fuck. Wobble, wobble, wobble. Oh, I'm really glad I had that banana. There, okay. Let's do the other sides. This one should be F6 to R3. Okay. Let's get a little dollop on solder on here. I hope this is as fun to watch as it is to do, because this is some struggle bus shit right here. Okay. Lessons in how not to solder with kitchen. Step 1. Don't get a third hand tool. Or step 1, get a third hand tool, hate it, throw it away, and never replace it. Ow. Step 2, burn yourself. And yes, I know, poor carpenter blames his tools. I'm not blaming my tools. I'm blaming my lack of the correct tools for the job. Right? Like, this would be so much easier if I had a specific tool. It's like trying to build a house and you don't have a tape measure. It's like, well, sure you can. I mean, it doesn't really have to be 16 inches on center. So long as it's the same, so you just cut a spacer and use that as your spacer between studs. It's fine. Now I say it doesn't have to be 16 inches on center. That's ignoring building codes. I'm literally just saying, like, you can throw up a wood frame structure without a tape measure. It's not that hard, but it's a lot easier with a tape measure. Okay. Something feels off about this, but I think it's correct. I think we're good. No, this is right. This is right. There's one more that needs to go in here, but this is correct. Okay. Now watch. I'm going to do all this stuff. And I'm going to turn the board on, and the LEDs aren't going to work again. Because that's just how life be sometimes. Okay, so that should be all the soldering for that step. Let's plug it in. See what happens. What did I say? Did I not say that I would plug this in after doing all that and the LEDs wouldn't work? Pretty sure I said that. Okay. They work. That scared me for a second. I was getting ready to flip this table over. Or go get another banana. One of the two. Oh, I didn't... my bad. Sorry. I forgot the most important thing. Not the most important thing, but a most important thing. Will it blend? And it will. Alright, so we have not one, but two functioning PCB jumbles. We are in the home stretch. I will say it. I was a little, maybe I shouldn't say it, but I went ahead and said it. So I'm going to clean up some stuff real quick here. So I've got tools, I've got knives, I've got meters, I've got shit everywhere. Need to put some of this stuff away. Oh, it does magnet there. Nice. And I want to say that's all the soldering I need to do. So I'm going to turn the iron off. And the fan. Okay. Oh no, it's not all the soldering I need to do. What am I talking about? I've got 42 switches I need to solder. And you know what? I said I was going to put box jades in this. Because I've got a bunch of box jades. Like, I accidentally bought 2 sets. So I have like 150 box jades or something like that. But I think I'm going to put Boba U4s in these. Because I am actually reasonably confident that this is a keyboard I want to use for a little while. And box jades. You know what? No, I'm going with box jades. The reason is because I want to give them a solid chance. Because everybody raves about them and the tactility and all that and the clicky. But I know this isn't a long-term board for me. Because it's too big for travel. It's just straight up too big. But I think I could. I mean, I've been using clickies in my my chalkboards for months now, so I can stand clickies for like use at home. So I'm gonna put clickies. Box Jades. Let's go. Alright. Install the switches. Insert the assembled PCBs into the case. Starting with the top row, install the 2 switches in the middle columns and solder them. Okay. So let's start with the right hand. Right hand. Set this one aside. Okay. Oh, it feels so weird to be like stuffing this thing in here. Okay, so starting with the top row, install the 2 switches in the middle columns and solder them. Okay. Here goes nothing. Oh, Boba, these are not plate or case mount. Or rather, these are plate mount switches. Okay. Which is fine, because it's a plate mount, but it's going to make it a little bit harder to get this in here, I think. Okay. Wrestle that. There we go. There we go. There we go. Okay. So... Wow. Yeah, this is... This is... Okay, so actually... I don't have to be super careful about not popping the switch out, because what's more important, I think anyways, is that the switch is flat against the PCB. Because then, once I get a couple, I'm assuming I'm gonna do like top and then bottom and then across. But we'll see. Once I get a couple in, it'll be held in enough. So I'm gonna do the just dollop of solder trick here to hold that, and that wasn't enough solder. Okay, let's see. Just to hold it in place enough. Okay. Well, that's not... Okay. Yeah? You think I should back out and put the U4s in? I think that'll be easier. I want to try these box jades, but I don't want to try them so much that it's like order of magnitude harder to assemble this keyboard. Try them. I mean, I have hot swap boards. Like, I can try them if I really feel like it. I am going to go back to the U4s. Okay. Let's get this out of here. And you know what? I don't know. Are all box jades plate mount, or are some PCB mount? I'm gonna look at... I've got 2 bags from 2 different vendors, so I'm gonna check the other one. Nope, the other bag is also plate mount. So, let me just... This doesn't feel like enough, but it's only a few more than I need. So let's see, 4, 6, 8, 10, 2, 4, 6, 8, 10. Yeah, that should be enough. So I've got a little solder here. I'm gonna clear that hole out. Oh yeah, that's much better. So much better. Because that is the switch, not soldered, holding the PCB in place. So much better. Because now, I can just go in here. And solder. Yeah, I'll do the box jades and something someday. Maybe if I ever put together my lilies or something. I've just been on a kick with chalkboards. Okay. Okay, this one's going to be a little harder, it seems. Got a little bit of a bent switch leg there. Okay. Alright, there's gotta be a trick to this. I wonder if I should have done this one first, and then this. I'll try that on the other hand. Okay, let's see if I can get some solder on that leg. Enough to hold it in place, maybe? Question mark? Okay. Okay. So, I need to resolder that leg, that switch. But I'm not going to do it right now because that switch is also the only thing, the solder connections there are the only thing holding that in place. So I want to get a couple more things holding this keyboard or holding that PCB down. So like the bottom one or something like that before I try. Before I redo that. So I'm going to put a little dab on there, or a little piece of tape on there to make sure I remember. Precision pliers to hold. You're not talking about this though, right? Because this isn't, I don't think, strong enough. These are locking tweezers. I don't think the clamp is enough. Okay. Case will melt and be damaged irreparably. Yeah, I'm fine with that. Solid 2 switches around it. Oh, speaking of things, I checked in my link settings, and there is explicitly a thing that says don't allow links, and it's unchecked. So I don't know why nobody can post links, but you can't post links, and I don't know why. But you should be able to. So if you post a link, say you posted a link, and then I'll try to see, because I don't know if... The reason this is relevant is because I was going to ask Quentin if you could link me to what you're talking about. Okay, install the switches around it. I don't see. I just see just posted a shameless advertisement, and then Leah says, "Is that a link?" I don't see a link at all. Didn't you link that to me on Discord, Quentin? Yeah, I don't see him at all either. I don't know. It's weird. And I have switched to where I'm looking at live chat, not top chat. Maybe I'll file a support ticket with YouTube at some point. I don't know. Oh, but see now... Okay, well, no, that's fine. I was going to say, now this is pushed up a little bit. It's not flush with the surface. But I need to... Oh, no, that's not one I needed to resolder. Okay, well, I'll figure it out later. Okay. So based on the switches, just saying, expectations, I'm probably not going to finish this today. Because this is going to take a long time in itself. So there will be a short stream, or another stream probably tomorrow. Hopefully tomorrow. We'll see. Okay, starting with the top row, install 2 switches in the middle, then install the switches around, or finish the top row. Install the 2 switches around it. So that's these 2. Wow, this is really tough. Yeah. There we go. Oh my god, get in there. Hurry. There. Yay. Okay. Holy crap. That took some doing. Okay. Okay, so those are flat. I'm gonna solder these real quick. And then I'm gonna fix this one. Okay, that should be in focus enough. Okay. And then this switch, I just want to flow. Ow, that's my finger. Okay, so I need to fix that one too. What's happening here on this one, it's hard to see, but this is lifted on the side just a little bit. And the reason is because there's a little gap between the switch and the PCB on the back. And so since this whole thing wants to twist this way, the PCB is pushing against the plate instead of the switch pushing against the plate. So it's lifting it up on the side. So what I'm trying to do is push the switch in and reflow the PCB, or reflow the legs so the PCB will hold better. The problem is I'm not eliminating that gap. So I need like something to hold the switch on one side, something to hold the soldering iron, and something to squeeze the whole damn thing together. So I need like a little C-clamp. Or hopefully what Quentin tried to link to. Quentin, can you paste me, can you link me that in Discord? And I'll repost the link in the channel or in the chat. And also probably buy whatever it is you're shamelessly linking. Okay. So before this gets too much farther, I want to get these in. Okay. Man, these PCBs... So I will say these PCBs are a lot more flexible than you might think. So, like, feel free to really wrench on them. I think that's the biggest thing I've struggled with so far. 5 hands. You mean the thing that... with all the little clips? I don't think those are... this needs a lot of force to push this, to sandwich this together. I need like a C-clamp. Normally closed tweezers. Okay, I have those. Or not, they're not normally closed, but I have locking tweezers. They put a decent amount of force on there. But that doesn't go around, that I can't do this with it. I mean, I can, but that's not really putting a lot of force on things. I mean, maybe I'll try it. So that needs to push on the switch. Yeah, no, see, that doesn't... I can't get it on the switch and that. And I can't get it through there or through this way, maybe? Nope. I need like a C-clamp for this one, I think. Okay. Finish the top row. It says. And I wish I could post images into the chat. Music might be done. Nope. It's just a lull. Okay. And actually, I'm gonna pop this back out. Because I want to be able to push on it from here. So I'm not gonna lie. I feel like hand wiring this would almost be easier. The one downside you get is you don't have RGBs, but if you got there's a there are the amoebas, the single switch PCBs that are good for hand wiring because they've got all the, like, you just wire, it's got like row, column, and it's internally all traced and everything through with diode port or diode pads and everything. I think there is a revision of those, or someone makes similar thing that has support for RGBs and even hot swap sockets, although hot swap sockets don't make a whole lot of sense on this because you'd have to attach them to the case somehow. But that is a thing that is possible. People have done it, I'm sure. But I feel like hand wiring this would be easier just because of the issues that I'm running into with, like, having to really clamp things and stuff like that to get the actual PCB onto the switch. And doesn't need, like I said, it doesn't need to be fully hand wired. Like, you can do amoebas, because those are just, you know, connect the dots, basically. I think if the connections between the PCBs were a little more flexible, which I don't think is possible with just, like, you know, hey, I want to print this PCB onto, you know, some flex PCB stuff. I don't think you can really do that. But, like, more flexible in, like, their little cables instead of actual PCB material. Because then each individual column shouldn't be that hard to get correct. And you don't have to worry about twisting the whole thing. This is just my thoughts. I'm not trying to be like, don't build this, or this is terrible, or anything like that. Absolutely not. And, like, hand wiring, I've never done it, but I understand enough about the matrix and stuff like that to know roughly how to do it if I had to. So, like, it's not that intimidating to me. This might be less intimidating to people than hand wiring. So it's good to have this kind of thing. But anyways, that's just my thoughts. I feel like hand wiring or some sort of revision to this, like, this is a great step. I think there are some improvements that could be made. I don't know if they're possible, I guess is what I'm trying to say. I don't know what I'm trying to say. This is fun, but damn, it is not easy. Okay. Careful not to damage the ribbon cables or the case. Okay, so finish the top row, do the bottom row in the same way. The PCB won't hold onto the switches. You can hold it with a soldering iron and then add the tin. Yeah. Because, like, when you're bending this lower column here, like, you really gotta put a lot of force into, and it's just, yeah. And this is why I scheduled multiple days for the stream, because I knew it wasn't going to be easy. Yeah, because, I mean, even getting this third switch in the bottom here, like, I feel like I need to almost... Let's see, I'm going to pop the switch out. I'm going to push the PCB, and then I'm going to try to push the switch in. Well, that doesn't help things. Okay. Okay, that actually worked really nicely. I wonder if I've been doing it wrong the whole time. So what I did there was I took the switch out, I pushed the PCB against the plate, and then I pushed the switch into there, and it is holding in place pretty well. That one's still... Oh, and I might have messed up that LED. Damn it. Let me just check. Nope. It's fine. Yeah, I wonder if doing that on top row would help as well. I'm going to try it when I switch to the other side. We'll see. But before I do that even, I'm going to add a little solder onto these now that I've got that column kind of set. Yeah, this column is a little messy. But we'll get there. We'll come back to that. Alright. Now the fun part. Getting this one under there. Okay. Push the plate or the PCB. It's the plate, and then switch into the PCB. Okay, so this one is loose enough that I don't need to do that, but it also means that I can't it won't hold itself in place while I solder, so I need to do this. sweet. I am super, super happy that you are here watching this and updating the build guide as I run into things. That's awesome. Because that's hopefully going to make it easier for the next person who builds one of these. Which in so many ways is my goal for doing these things, is to kind of serve in some ways as documentation for how to do it, or, you know, that it's possible, or tips and tricks, or whatever. So that's awesome. Thank you. I really appreciate that. Genuinely do. And I appreciate you being here to be in the peanut gallery either way. Which goes for the rest of you too. Thank you all for being here. And for those of you who watch later... Okay, well, we're getting there. Making progress. Okay. Whoops. And actually, you know, since I don't really need this right now, it's not changing a lot, I'm going to just close that. Now, see, this one, I can grab it from the side with these. Still doesn't quite get it flush. Okay. So one thing I'm going to struggle with here is this PCB lays flat against that, against this. But these are soldered on here and need to be flush cut, or at least cut much closer. I think it'd probably be fine either way because this is trying to pull the switch away. So it'll hold the switch against the plate instead of the switch needing to holding the PCB against the plate. But it's something that I need to consider either way. Okay. And I'm sorry, this is probably really hard to see what I'm doing. Because, like, trying to do this in such a way that I can see it and you can see it with all the stuff that's in the way, with the flappy things and the just tight spaces and stuff. Sorry. I'm acknowledging it straight up. I'm doing a crappy job with camera work today, but honestly, like, unless you're looking directly from my perspective, like, it's just really hard to try to do this on camera. So, sorry. Maybe when I get 100,000 subscribers and I have a camera person instead of just a fixed camera attached to my desk. Which isn't even all that fixed, because it's shitty. I'm trying. I'm really trying. But I'm not... I could be doing better, and I'm just not, and I'm not going to, so... Apologies. That type of thing is definitely a edited down how-to video thing if I was going to try to, like, make it so you could see every little thing that I'm working on. Because then I would care more about, like, making sure the shot is in place. I would have, like, this held perfectly, you know, all that stuff that I'm not doing for streaming. But hopefully someday we'll do for longer form, or not longer form, but like video form content rather than streaming. Okay, so we've got top and bottom row. This column here, because of the way it's trying to flex, those two need to get fixed. Because they're both pushed up just a little bit, but I'll fix that later. And it's pretty obvious, so it's not going to be, hopefully not going to be something I forget about. And yeah, I am going to do the rest of this side and call it a day. Because that's going to take me another probably 45 minutes is my guess. Half an hour, 45 minutes. And then to assemble it all and test it and stuff like that. That'll give a nice 3 hours or so of stream. And then I'll come back and hopefully do it all tomorrow, or finish the rest of it up tomorrow. But we're making good progress, I think. I feel good about my progress so far. Now I'm just going to do... I should just be able to pop these switches in. Because they should be as flush against the PCB as they're going to get. Or sorry, as the PCB should be as flush against the case as it's going to get. Okay. So this one here, I want to push it in a little further, but it's not pushing into the PCB more. It's pushing the PCB out, so I need to kind of... I think I need to trim just a tiny bit of material off of the legs. Just like... Just a tiny, tiny bit. Where's the knife? Whoops. Wait, that was on this side. That was the wrong leg I shaved material off of. That's fine. Alright, it's still pushing up just a little bit. I think what this might be actually is just on the edges here. Because the board is curved, and I'm trying to push this into there. Getting there. I'm getting closer. Basically, I'm trying to find, when I push this in, where the contact points are of the board and the switch. I mean, really, that's actually just good. That's good enough. It's fine. It doesn't have to be perfect. There's probably enough play in the switch itself to make that not noticeable. And then I can get in on this one through the side. Okay. Yeah, I'm gonna say, because of the way the PCB wants to flex and push the switches out, this would be an easier build as a hand wire. Because then you get the switches to snap in place, and the switches, because you always want the switches to drive the alignment of the everything else. Like if you're doing a plate build, because otherwise, like if this one is a little sideways, you might have cap interference issues between these two switches, and so you put the switches so the switches are the plane that you're planning for, I guess. And the hand wire build, you don't have, or you won't have the switches trying to get twisted off of the plate by the PCB, because there is no PCB. It's just a bunch of wires connecting in the back. And even with like a amoeba PCB, because the PCB isn't attached to other PCBs, you won't have the same problem. Because like this column is just twisted. And that's just because it's trying to, yeah, I don't know. Hard to describe. And then the center row here wants to lift up off of the switch plate a little bit because the PCBs are getting pushed against the plate. And yeah, it's just, yeah. Just some thoughts I have on this. Maybe I will build another one at some point with clicky switches. And just hand wire it. I do really, really dig this breakout though for the controller. I think that would be good for even a hand wire build. Although there are some like controllers that are specifically set up for hand wire builds with the pins around the edges and stuff like that. So we'll see. I hopefully will be doing a hand wire build soon. A very small hand wire build. There's an artsy keyboard. I don't even know if it has a name, but it's an artsy keyboard. Artsy is a 6 or 8 finger single-handed chording layout that's becoming rather popular, or at least I've seen pop up from time to time, that I want to play around with. And the board that I want to build is basically just a 3D printed case, and you hand wire the whole thing. Because it's only 8 switches, you don't need diodes, just stuff like that. It's just, you know, it's not a super complex hand wire build. But it should be fun. And then I get to play with Artsy, which I want to do because that seems like it could be fun too. And plus I love weird keyboards. Like I have a Ginny, or Guinea, I think it's Ginny, from Gboards, from Jane. And I can type on it, although it's been a long time, so I'd have to take a little refresher course. But I just want to be able to go through like airport security or customs at some point, and someone look at my artsy keyboard and they'd be like, the hell is this? And I'll be like, it's a keyboard. And then they're like, no, it can't be. Where are all the keys? And I'm like, well, let me plug it in. I can show you how to type on it. It is totally a keyboard. And then I got arrested and all that stuff. Just because. Okay, that is all of those switches. So this flips over and plops into here, and these seem to be at least mostly all in the same plane. So hopefully, oh, but they're also in need of trimming. Yeah, when I first saw the Ginny, it blew my mind. I was like, you can't type on that. And then I looked up a Setniop, and I was like, oh, wow. And there's a Dvorak variant of a Setniop called AOEIHTNS. It's basically the Dvorak home row, except instead of U on the top level, it's I, which is a little disorienting at first. But I learned that layout enough to be able to type a little bit. But I learned that layout. There's a, if you go to a Setniop, if you just Google for a Setniop, there's a website where you can actually type and on just using a regular keyboard, and it emulates it for you, which is really handy because it'll show you, like, you hold down the A key and it shows you what chords. It is not just you. The music did stop. Probably it ran out. Because I had a little mini playlist going and it probably just ran out. But it shows you what chords are available on that key, which is handy while you're waiting for your brain to start working, for your muscle memory to kick in. Let's go Chill Hop Spring 2021. Oh, let's see, that's only 40 seconds. Oh no, this is a whole album. It's only 12 minutes though. Okay, hang on. I'm gonna clear the playlist. Clear. And add. Play next. Later. Okay. There. Music should be back now. I have not tried doing any steno stuff, and I don't know if I want to, because the problem with steno is I feel like to do it right, you really need like Plover or one of those other third-party tools, and that's great, but I don't think I can get that for the iPad. And since the iPad is my primary computer nowadays, it's important that whatever typing situation I have works on my iPad. And that just won't. Okay, this probably even says... Nope, it just says install the switches on the thumb cluster. Okay. And sure, there are things you can do, like, there's a lot of stuff you can do that's on the keyboard, but I really feel like for a lot of these chording solutions and stuff like that, or kind of the way of the future, I think is going to require operating system integration to some degree, because you need that feedback. Like right now, you know, I have vertical combos now on my home row keys. So basically, every time I type a keystroke, there's a 20 millisecond delay before it gets sent to the computer, because it's waiting for a combo. And if that combo happens, it sends a different code to the computer. Whereas if it was being done on the computer side, the computer could display the keyboard almost like a dead key, like on a Mac. If you hit Option E, let's say, that's for putting an accent on a letter, like for Spanish, Option E. it'll pop up a little thing that shows you that you hit a dead key for the accent marker. And then when you hit a vowel, it pops in the accented vowel. Or the accented letter, I should say, because I think it does more than just letters. Or vowels. I don't remember. But if you were to hit, say, N, which I don't believe is an accented character available through that method, then it just types N instead. So for like mod taps, it could show you the shift, and maybe like, so say you had shift on the letter T, which is a home row key on Dvorak. It could show you like a capital T, but kind of grayed out. And then if you hit the next key within the right time sequence or whatever, it will remove that and add the correct output there. But it gives you that visual feedback immediately rather than you having to maybe not even know that it's occurring under the hood because it's all built into your keyboard. And sure, you could have that visual feedback maybe on your OLED display or something like that, but I don't know about you, I don't look at my OLED displays when I'm typing. In fact, I only have a few keyboards that have OLED displays, and they don't have anything meaningful on them. They're just for bling factor. But then you have a problem of like, okay, well, one, you need to have operating system support across a wide variety of operating systems. You need to have a way to port those between both operating systems and user devices. All that stuff. So it makes sense to do a lot of that in keyboard. But then you lose that visual feedback. I don't know. That's kind of what I've been trying to figure out as of late. I think that's one of the main things that's blocking, or one of the main things that would block mainstream adoption of, quote, weird keyboards in like things like laptops and stuff like that. Which is why I think having a split spacebar is a great first step. Because you give someone the ability, you just dip your toes into having mods on a thumb key instead of on pinkies, or a layer on a thumb key, or something like that. And you're not sacrificing anything, because if someone doesn't like it, well, they can just make both of their spacebar keys spacebar, and nothing changes. Except for their keyboard looks a little weird. And I just melted the case. Awesome. And I've been seeing a lot of more normie keyboards in the mechanical keyboard community that have split space bars, and it's really exciting to me. Okay. That's that side. Let's test it. I'm assuming these are not configured with EE hands or anything like that, so this is going to be backward. Okay, so we have LEDs on everything. That's good. Let's get Safari back. Yeah, Daniel, I mean, they're, like, the Genie itself has a whole combo engine built in that does coding with words and stuff like that, but you're still missing that operating system level feedback. Oh, master right? Oh, okay, perfect. I was just assuming this was just going to be backward when I tested, and it was fine. Let's make this a touch wider so y'all can see it. Okay. Okay. Uh-oh. Does that just not do anything? Aha, it's a layer key. Perfect. So all the switches work, all the LEDs work. I'm gonna finish assembling this side. I think is the next step. Install the switches, test the keyboard, install the MCU adapter. Okay. We are getting close. You're getting so close. Ah. Okay, are these the same screws? They are not. Okay, so this is for the tenting screws. And I didn't realize it when I got this. One, that there's already a fairly decent tent built into the board. And two, that the tenting kit was so steep. I mean, that's ridiculous. That is way more tent than I really want. But that's fine. It's totally fine. I just think it's funny because it's like, wow, okay, that is a lot of tent. So I'm not going to put the tenting kit on just yet, because I want to test it without the tenting kit. And then I'll try it out, I'll play around with it. So we get the controller breakout in here. Push these down. Line things up here. Squeeze it in. Okay. Now, do I have in this bit set a big enough Torx? I believe the answer is no. I mean, well, that's not even Torx. Does it say what it is? It doesn't. Oh, that is the right size. Nice. Okay.
The survival of my people is at stake.
Okay. Install the MCU adapter. Install the plates. So I want to say these were sided because they have countersunk holes. Ah, and now I see why the RGB lines should go in from the other side, because they stick up, but that's fine because it'll still work.
Do you hear it? Hear it? Yes. Night after night, lying awake until dawn, waiting.
For what?
I don't know.
That's what I thought.
Boom. That is 1/2 done. I mean, it still needs caps. And really, I should probably try to fix these switches here. And I'm probably going to end up doing it. I forgot about that. Because there's... I mean, this one is significantly lifted on the one side. But I'll mess around with that at a future point. Or at least maybe tomorrow. Maybe tomorrow if I get particularly feeling like I want to do it. But yeah, that is 1/2 done. And I could maybe like this. I like the size. I think the size is good. I will say I wish I had gotten the skeletal because it's a 5 column instead of 6. I don't know if I thought about it too much or I just like jumped on it, but it's fine. Maybe I'll get a skeletal and I'll hand wire that one. Who knows? But that's 1/2 done. So I'm gonna call that here for today because we're 2 hours 45 minutes. It's a good stream. Tomorrow we'll take a little bit what we learned today. And do the other half. And that should go pretty quick. I say quick, it'll probably still take me an hour and a half or more. But it'll go fairly quick, and then I'll try it out. I'll type on it and maybe see if I can't fix the columns on the other hand and whatnot. But I am very pleased with the progress today. I think there's not a whole lot left, and yeah. I'm excited about this. Speaking of being excited about stuff, I want to talk about what I'm going to do next week. Or at least I think I'm going to do next week, if I can get the parts for it. One of the boards I want to build next week is called the Fisher keyboard. Fissure. The Fisher keyboard is hard to tell what it is from looking at it like this. Let me get rid of Safari. But in many ways, it is very, very, very similar to this board. Because what the Fisher does is it's in 3 different pieces. And you make a 3-dimensional keyboard out of it. And this maybe it's backward. I don't know exactly how to put it together. But this is the thumb cluster. This props up the rest of the board, and it tents this. So the whole thing kind of comes together like this, with this in the middle. And that's really, really interesting and cool. I'm looking at this and I'm already seeing some filing I'm probably gonna have to do, and some other stuff to get this to work. But this is a pretty cool board. Now, the reason I say I don't know if I'm going to get to it next week is because, one, I need to get surface mount TRRS jacks, which I don't have. I might be able to mod the ones I have into it by just bending the legs, so I might try that. But at the very least, I need to figure out something here. The more I look at this board now, there's this. I don't know what that is. So I'm going to have to look up the bill of materials. This is not a kit that I bought from somewhere. This is, Shoggot on various Discords. We basically traded PCBs. I sent him one of the pairs of PCBs I got for the TBK Mini corne that I built, and he sent me this in return. What's funny is, like, I sent him one of them and he never got it, and he was like, what's up, dude? I bought switches for this and everything, like, you know, is that ever gonna show up? Are you gonna ever ship it off? And I'm like, dude, I shipped it like 2 months ago, I thought. So I'm like, okay, well, I've got another one. I just sent him another pair. So he gets the second pair. And then, like, 3 weeks later, gets the first pair. And it's not like this is international or anything like that. I sent it to him. He lives on the East Coast, right? So, like, I sent it across the US, and it took, like, 2.5 months to get there. Fortunately, the second one I put tracking on. I was like, well, it's only a couple bucks extra. I get tracking, and then I'm like, I can at least go, no, dude, I sent you the tracking number. That's where it is. It's out of my hands. Because I didn't know if I sent him the first one or not. I was like, did I? Because I sent a bunch of mail that day. I sent some to Europe. I sent some to Texas. I sent some wherever. But, you know, maybe I missed his, right? But I was pretty sure I sent it. And it turns out I did. It just took 4 months or something, 3 months, several months to show up. So he sent me this. And he sent me, I don't remember the name of this one, but this odd thing. It's like a, I don't even know how to describe it. It's hard pinky stagger, but only 2 keys on the pinky, and it's twisted. And I don't even know. I don't even know. And actually, I'm looking at it. Where are the diode pads? Where do you put the diodes on this thing? It's got hot swap sockets, but nowhere to put diodes. This may not be buildable, or it may require a different controller. I don't know. I'm going to have to ask him. I don't know when I'll get around to this. I probably won't get around to it for a long time because I just have a big pile of other boards that are ready to get built. So I'm hoping to get started on this next week. Or I say get started. I'm hoping to build this next week. This should be a pretty fast build because there's no LEDs. It's just diodes. It should be pretty quick. And it's soldered switches. So yeah. But I've got a couple of other builds that I have in the pipe. And yeah. So anyways, I'm gonna stop rambling. Tomorrow, assuming the stream. Yeah, you don't need diodes. You just get ghosting. Yeah. And, you know, for a board that is just going to go onto a shelf, I don't really care about ghosting, so sure. Anyways, tomorrow, finish this board up, assuming I can tomorrow. I haven't heard anything about the construction tomorrow, but I'm hoping there won't be construction tomorrow. If there is construction tomorrow, I'll stream on Saturday, because weekends I've been told are safe, so I can stream on Saturday. But I'm gonna shoot for tomorrow. So, anyways, that's it. And if I get done early tomorrow, maybe I'll throw this together. Because if I don't need diodes, this is just a simple hot swap. I've got switches. I don't have controllers. I think I'm running low on controllers. So, anyways, that's it. I'm gonna go do something else for a little bit. Thank you all for sticking it with me on this. This has been a really fun, challenging build. It's tested my troubleshooting skills. It's tested my patience. It's been good. I've enjoyed this very much. So thank you all for hanging out, and hopefully I'll see you tomorrow. Otherwise, see you Saturday, and we'll get this all finished up. Have a great day.